Let's dive right in and investigate what is without a doubt the most hostile crime scene in our entire solar system. In today's Explainer, we're heading over to the second planet from the Sun to explore a toxic, scorching hellscape that we lovingly call Earth's evil twin. Welcome to Venus. So you've got to wonder, how exactly did a planet born from the exact same cosmic materials as Earth, sitting right next door in our solar neighborhood, turn into an absolute nightmare? I mean, how did a world with such a similar starting point diverge so catastrophically from our own beautiful, blue, habitable home? If you put them side by side, it's super obvious why we call them twins. Venus is just a tiny bit smaller than Earth, holding on to over 80% of our planet's mass. Honestly, from a distance, you might even think they're identical. But let me tell you, the second you drop below those thick Venusian clouds, the similarities violently end. If you were to somehow stand on the surface of Venus, you would instantly feel an atmospheric pressure 92 times greater than what we feel right now on Earth. Try to imagine that weight for a second. It's literally the equivalent of being 3,000 feet underwater in a nuclear submarine. Humans, our heavily armored spacecraft, everything just gets instantly crushed under the immense weight of an atmosphere that is way thicker and denser than any other rocky body in the solar system. And to make matters worse, the surface temperature is a sweltering 880 degrees Fahrenheit. That's 470 degrees Celsius. We're talking hot enough to turn solid metals like lead, tin, and zinc into puddles of melted liquid right there on the ground. In fact, the carbon dioxide down there is pressurized and heated so intensely that it actually stops acting like a normal gas. It becomes what scientists call a supercritical fluid. So picture this bizarre, ultra-thick haze just sloshing around the surface like a boiling ocean. Wild, right? You know, decades ago, the Soviet Union actually sent a series of heavily armored Venera landers down to the surface. It was this incredible test of human engineering, but spoiler alert, the planet won. Even these hardened, literal tank-like probes could only survive a couple of hours before the brutal heat, the crushing pressure, and, the sulfuric acid rain completely destroyed them. Section 1. The anomalies. The backwards planet. So Venus is the only rocky planet that rotates backwards. We call this retrograde rotation. What that means for you is if you could somehow survive standing on the surface and look up through those permanent thick clouds, the sun would actually rise in the west and set in the east. Scientists suspect that maybe a massive collision early in its history, or maybe just the intense tidal forces from its dense atmosphere, essentially flipped or stalled its spin. Now, because it spins so incredibly slowly, a single day on Venus, meaning one full rotation on its axis, takes 243 Earth days. But get this, its orbit around the sun is much faster. That means a single day on Venus actually lasts longer than its entire year. Let that sink in for a second. Section 2. The suspect. The runaway greenhouse effect. So what caused all this? Well, the primary suspect is the atmosphere itself. It's completely dominated by a massive 96.5% chunk of carbon dioxide. This ultra-thick blanket acts like an inescapable trap for solar heat. Interestingly, Venus actually absorbs less sunlight than Earth because its bright clouds reflect so much of it away. But the heat that does make it through, it simply cannot escape. It's essentially an oven stuck in self-cleaning mode. Let's trace back this catastrophic timeline. Scientists actually believe Venus once had Earth-like oceans, potentially hosting liquid water for up to 2 billion years. But as the young sun naturally grew hotter over time, those ancient oceans began to evaporate. Now, water vapor's a really potent greenhouse gas. So as more water entered the air, it trapped more heat, which created this vicious, unstoppable feedback loop that ultimately boiled all the water away forever. Furthermore, Venus lacks Earth's moving tectonic plates. Here on Earth, we use plate tectonics to scrub carbon dioxide out of the atmosphere and pull it deep down into the mantle. But Venus? It operates with what scientists call an episodic squishy lid. Yeah, squishy. Instead of moving plates, its surface is mostly a rigid, solid shell. So without tectonic plates acting as a giant planetary recycling system to scrub the air, all those massive amounts of carbon dioxide spewed out by volcanoes were left permanently trapped in the atmosphere. Section 3. The search for life. Mysteries in the clouds. But consider this stark contrast. If you travel about 50 kilometers up into those sulfuric acid clouds, the temperature suddenly drops to between 30 and 200 degrees Fahrenheit, and the pressure drops to right around 1 Earth atmosphere.
it suddenly becomes this incredibly Earth-like, surprisingly temperate band, just floating high above a literal hellscape.
And here's where things get really crazy. In 2020, scientists detected trace amounts of a gas called phosphine in these clouds. Now, on Earth, phosphine is a potential biomarker, meaning it's something produced by living organisms. This discovery sparked a massive, ongoing debate in the scientific community. Could hyperacedophilic microbes be surviving, right now, high up in the thick clouds of Venus? We don't have a definitive answer just yet, but the mere possibility of it is absolutely thrilling.
Section 4. The Next Generation of Sleuths.
To finally solve these lingering mysteries, we're entering a golden age of Venus exploration with an impressive armada of upcoming missions. We're talking NASA's Veritas and Da Vinci, the European Space Agency's Envision, and ISRO's Shukriyan. These spacecraft are going to deploy highly advanced radar and deep atmospheric probes to finally pierce through the veil of those Venusian clouds, map the hidden surface, and sample its chemical secrets firsthand.
Section 5. The Verdict. A Warning for Earth.
Ultimately, Venus stands as a stark natural laboratory. It shows us exactly what happens when a planetary greenhouse effect spirals entirely out of control. By studying exactly how and why Venus failed, we learn the precise mechanical and chemical boundaries required to keep a terrestrial planet like ours habitable. As we continue to navigate and study our own climate change right here at home, investigating Venus might actually be the ultimate key to understanding and protecting the fragile habitability of Earth. So, will Earth forever remain the habitable twin, or could we, one day, face the exact same fate? That is the profound, somewhat terrifying question Venus forces us to ask. Thanks so much for joining me for this explainer, and keep exploring.